Okay, welcome to Unit 4, Lesson 11, Introducing the Number I. Let's meet I. Okay, here's our complex numbers. We saw this before in the last lesson. Complex is a real number plus an imaginary number. So it should look in standard form like that. Our imaginary numbers are I. So a complex number again. And then I is the square root of -1. That's what I is the square root of -1. Okay, and we're going to come back to this later, but get familiar with these numbers. You're going to have to memorize the powers of I. Okay, so find the value of each expression mentally. So this is 2 squared times √3 squared, which is 4 times 3, which is 12. This is 1/2 squared times √3 squared. 1/2 squared is 1/4 times 3 equals 3/4. Okay, when we have two terms inside of a parentheses, we distribute the 2 to both terms. So this becomes 2 squared times the square root of -1 squared. 2 squared is 4. The square root of -1 squared is -1, which gives us -4. And then finally, 1/2 squared times the square root of -1 squared gives us 1/4 times -1, which is -1/4. Okay, so because there are two terms in here, you can distribute the 2 to both terms. And when you square a square root, they undo each other and you get rid of the radical symbol. Okay, find solutions to these equations, then plot the solutions to each equation. A squared. The square root of A should be 2 roots. Should be +4 and -4. I think the book wants us to deal with the positive side only, so I will deal with the positive side only. Now, b squared equals -9. This is going to be a little different. When we take the square root, b is, what do you have to do? Now, before we talked about complex numbers, you could not do this. This would be not real. But what we're going to do now is separate the radical into -1 times 9. And we know the square root of 9 is 3. But the square root of -1 is called I. So we get 3i. And that means b goes here, or 2 goes here. That's b. And then finally, c. Take the square root of both sides. C is the square root of -1 times 5, √5 times I. But we don't put the I after the real number. We put the I in front of a radical so we don't confuse that the I is is under the radical symbol with the number. So the square root of 5 is about 2. It's a little bit more than 2. And so it's a little bit above 2i. So C goes there. Okay, write these imaginary numbers using the I. So what you're going to have to do is separate the radical into -1 times 36. The square root of 36 is 6. The square root of -1 is I. With -10, separate it into -1 times 10. 10 is not a perfect square, so this is I √10. We put the I in front of a radical symbol so we don't confuse the I as underneath the radical symbol. With number 3, the negative stays outside. Separate -1 times 100. The square root of 100 is 10, so this is -10i. The square root of -1 is I, so it's -10i is the answer. And then finally for 17, for 4, the negative of -1 times 17. 17 is not perfect. It can't be simplified. So we have -I times √17. Okay, when we add a real number and an imaginary number, we get what's called a complex number. The diagram shows where 3 minus 2i is in the complex plane because these are your real numbers and these are imaginary. It works like xy, but we have different things on the axes. What complex number is represented by point A? So basically, you go back 4, so that's negative 4, and then you go up 1, 2, 3, plus 3i. So this is negative 4 plus 3i as point A. Okay, let's plot these points. All right, so starting at the origin, we go negative 2 minus I. So that's A. B. Negative 6 plus 3i. Negative 6 is here, plus 3i is here. So that's B. C. 5 plus 4i. So we go over to 5, we go up 4. That's right there. That's point C. And then finally, point D is 1 minus 3i. 1 minus 3i is right there.